Okay, so this is the chapter on salts, and if you can get the textbook, read the textbook, it's good. The textbook is Martian Cavendish. It's quite clear. Huh? So for salt preparation chapter, there's three main aspects of this chapter that you need to know. Number one is what are salts? What are the soluble and insoluble salts? Then how to, based on the category of it being soluble or insoluble, then you will be tasked to actually learn how to actually prepare them. So preparing them, there is three main methods which you need to know: crystallization, titration, and finally precipitation. So in exam, they will ask you to write the procedure and suggest what are the reactants to form the salts provided. Then finally, we have qualitative analysis. This one is more towards of practical, where you have to remember the kinds of ions, cations or anions, that can be produced through a series of tests and procedure. If you are taking science chemistry, then what will happen is you will be seeing a flowchart kind of question over in your O-level examination. Okay. So first of all, what is a salt? So a salt is mainly a compound when the hydrogen ion of the acid is replaced by the metallic ion or an ammonium ion. Now what this means is actually a salt is something like it contains two main parts. They contain the cation and the anion. Now when we talk about cation, right, usually the cation part is either formed by the metallic ion, usually comes from, it's either the metallic ion or the ammonium ion. How do you differentiate this one? Usually it has something for plus as a superscript. Okay, of course it has also other forms or other numbers like plus 2 plus 3 plus, etc. The anion on the other hand tends to come from the acid you use. Okay, like for example, the three kinds common acid that we usually use is hydrochloric acid, your nitric acid, and your sulfuric acid. All of these, what is the anion for all these is mainly minus and then 2H plus SO4 2 minus. So when the question actually say replace the hydrogen ions, we are talking about these hydrogen ions. They are being replaced with either a metallic ion or your ammonium ion, which is your cation. And the ones in orange are the anions. So these anions tends to actually be replaced over here. Now this is only if it's an acid reaction. However, if there is other forms like precipitation or other metals, then it'll be different. But more commonly, you'll be able to identify all this. Okay, and together they form the salt. Now, so in a nutshell, the salt is mainly made of two parts, like what I've actually shared. And to even segregate it further, right, the cation can come from the base. Okay, and the anion can also include a non-metallic ion. So generally, this is the ingredients or the body of a salt. So when we look at this example of zinc sulfate usually forms from your zinc, can be formed from your zinc hydroxide, which is a base, or in other words, in this case, because you have a hydroxide, right, it tends to be either an alkali, a soluble base. Following this is your acid, and what you realize in your chapter on acid and base, this is actually a neutralization reaction that forms your salt and water. So you will find that the cation tends to actually form here, whereas for the anion comes from the acid, and together you are actually able to form a salt. So this is what we call as the salt zinc sulfate as ZnSO4. Now how do you get this kind of combination is, if we look at the base, it's Zn2 plus. How to get the charge 2 plus, you can revise the previous few chapters. For these are mainly polyanions that you can first memorize. And what happens is, how do we find the salt then? Remember the cross method, whereby the charge of the ions are intercrossed. And what will happen is this will actually lead to your zinc having a 2 and your SO4 whole thing to have a 2. Okay, of course you remove the symbol of the minus and plus. But at the same time, because both of these numbers, right, they tend to be the same. So you actually present it to a simpler ratio, and therefore you get ZnSO4, which is the name of the salt. So when we look at sodium chloride again, you have your sodium cation and your chloride anion. So together, when you actually do the cross again, you actually form NaCl. Where over here you would see that the hydroxide ion, the H plus ion is being replaced by your Na plus, and of course, this is what we call as salt. Again, this is actually a neutralization reaction where you have a base plus the alkali to give you your salt and water. So what are some reactions in which salt can be made? We could see that there is either a metal, carbonate, acid, and salt formation. But more importantly, if you remember our 3 general word equation that we actually learnt in the acid-base reaction, where metal, when react with either an acid, you get the salt plus hydrogen gas. A carbonate, when react with an acid, you will actually form an acid. You will actually form a salt plus carbon dioxide gas plus water. And of course, your base, when react with your acid, you could actually form your salt plus water. So generally, these 3 reactions can fall into this category where the one that is consistent is the acid. Then of course the one in the carbonate, you'll get you will actually be able to contribute your cation. So what we can see is all these factor over here contributes your cation, and your acid will contribute your anion, part of the salt preparation. Okay, so a reactive metal can react with react with a hydrochloric acid, you will actually form zinc chloride. So usually we remember the ions for acid. So ions for acid, if it's a hydrochloric acid, it's a chloride. If it's a nitric acid, it's a nitrate. Sulfuric acid is a sulfate. Okay, and do take note that there are certain acid reactions that cannot take place either because of the reactants not being very stable. For example, copper when react with acid, you will not tend to have any form of reaction because copper tends to be quite unreactive. So what is a better way to, if you are interested to form a copper salt, you will want to use a carbonate in this case. Okay, now of course there are some metals that are very reactive. For example, potassium, when you react with acid, you will actually get a very mini explosive kind of reaction. So it's also very dangerous to prepare in the lab. That's why what you want to do is then use base, maybe like potassium hydroxide, to react with the acid to still form your reaction, your salt that you are interested in. So how is this important? This process, right, helps to do a lot of drug discovery where salt is a form of medication or pill. So to actually use this kind of reactants, what we want in industry is to make it safe, and of course to scale it in terms of the efficiency. Okay, so next we look at salt. When we look at salt, there is also the part of crystallization, water of crystallization. Now, what is this water of crystallization? If you remember in your previous few chapter, you will have at least done one form of crystallization with copper 2 sulfate. This is this very blue color crystal that you actually form. Now the reason why there is that shine, that blue color shine, it's because of the water of crystallization that gives it its shine. And that if you for those students who actually try to overheat it, you realize that the copper 2 sulfate actually became more white colorish kind of thing, because most of the water crystallization has been lost, leading to the decomposition of the crystal. So the water present in the crystals tend to give it its crystalline properties and can be easily removed by heating. So in exam, we tend to use the terms hydrated and anhydrous to relate whether the salt is dry or whether it contains water of crystallization. For example, for hydrated salt, it will contain water of crystallization, while anhydrous salts, they tend to actually not contain water of crystallization. So like what was being shared just now, when we take a look at this, copper 2 sulfate, they tend to be like bluish color, and this is because there is the hydrated form. Now, are you required to write this water of crystallization in your equation? Ideally you should, but for secondary schools exam, we tend not to actually include this. But should we want to include the water of crystallization, we tend to use a dot to actually cover it, so that we could say that the water crystallization is attached to that specific salt that is present and not actually excluded. This is very different from, let's say just now we talk about the neutralization reaction, where you see this is the water. Now this is not the water of crystallization for salt, the salt sodium chloride, it's just water as a separate compound. Okay, so this dot will actually indicate that the water crystallization is for that specific crystal. Now, salt has various types of solubility. All salts containing sodium, potassium, and of course ammonium ions, they tend to be very soluble in water. This is something that you have to memorize one. And because they are actually soluble in water, we tend to say that these salts are actually soluble salts. And then another one is actually your nitrates. Your nitrates usually end with an NO3. So these are examples of soluble salts. However, there are a few exceptions. Like for example, all chlorides are soluble except these two. What is these two? This is actually your lead chloride. You can say lead 2 chloride. And also this is silver chloride. All sulfates are also soluble except BaSO4, CaSO4, and of course PbSO4, which again is your barium sulfate, calcium sulfate, and of course your lead 2 sulfate. All carbonates are insoluble except sodium carbonate, potassium carbonate, and ammonium carbonate. Now do take note that all these three they are actually soluble, whereas the other carbonates, they tend to be insoluble. So all these are things that you have to memorize by heart. You definitely you will not be able to remember after watching this video. It takes a lot of mindful practices to remember this, and this is key. Because the thing is, if you don't even know how to classify a salt being soluble or insoluble, you will not be able to actually decide what kind of method it is suitable to prepare the salt. And if you do not know which method to prepare, you will not be able to identify what form of reactants you should choose to prepare the salt. So at least the first basis, you need to memorize this. This is very important. It is examinable in that sense. So one simple way that you can remember is having a table like this, where all nitrates are soluble, and when we say sodium, potassium, ammonia, you can remember it as SPA. So all SPA salts are soluble. Okay, it means that as long as you have the sodium, potassium, ammonium, you see in the chemical symbol, just take it that it is soluble. All chlorides soluble, all sulfates are soluble. Okay, so these are some of the things to take note. So you can even remember things like NCS, as soluble salts. Alright, let me just charge a bit. So far, got any question? Is it clear? Don't worry, I'll cut off the video.
I know there's this like snacks, like SNACKS, like some
Acronym, is it?
acronym.
S
Snacks.
A
I don't know what it means. I remember.
S N A C K. Oh, and then S.
S, yeah.
Okay. Yeah, resume okay. Another way to remember all these is using the word snacks, SNACKS, where S represents sodium here, N represents nitrates here, A represents ammonium here, C represents your chlorides, K represents your potassium because potassium's chemical symbol is K, and then the last S is actually your sulfates. Okay, so this is another way to remember soluble salts. Now, when we look at insoluble salts, right? Insoluble salts, you can remember it as your carbonates. Your carbonates tend to be insoluble. You have your silver chloride and lead chloride. This one you can remember it as maybe your student leaders. Then of course, over here your barium sulfate, lead 2 sulfate, calcium sulfate, which is maybe CBL, which is like maybe challenge-based learning. So these are some acronyms that you can try to remember in the form of what are insoluble salts. Okay, now we'll move on to, after you have already memorized what are the different kinds of salt preparation, the how soluble and insoluble salt, we will look at how to prepare salts. So generally, how to prepare salts, you need to consider two main things. Is the salt soluble in water? That's the first one. Second one is the reactant soluble? So how is this going to play a role? So if we look at salt, if it is, okay, so just to take note, we have three main methods. Crystallization, precipitation, and of course titration. So for the first question of is salt soluble or insoluble, if it's soluble, if it's insoluble. If it's insoluble, you will definitely use the precipitation method. Okay, this is where you use two different kinds of compounds, maybe salts, and then add them together, and you will generally generate some form of insoluble salt eventually. For soluble salt, the second question we'll raise is the reactant soluble? Reactant soluble in water, or the reactant is insoluble in water? So if the reactant is soluble in water, what will happen is you tend to use titration. If the reactant is insoluble in water, you will tend to use crystallization. Okay, so what happens is you fall back again on the three word equations, or three equations from an acid-base reaction, which is metal plus acid give you salt plus water. Your carbonate, sorry, not salt plus water, but hydrogen gas. Your carbonate plus acid gives you salt, carbon dioxide gas, and water. And last but not least, you have your base plus acid to give you salt and water. So one thing to note is that your acid is always soluble. If an acid is actually a substance when dissolved in water, only when dissolved in water is able to release the H plus ions, then it's considered an acid. So what happens is the one that is actually the reactant that is insoluble in water, therefore has to be either your metal, your carbonate, or your base. And how do you see it from your state symbol? Anything that tends to be able to dissolve in water, we usually use the AQ symbol. Whereas anything that is insoluble, of course, we tend to use the word solid. Metals, there is no gaseous form in this case lah. So it tends to be solid in this. Second thing is the salt. The salt can be also in the aqueous form because these are soluble salts. Then the rest is just as per normal, the state symbol. Like hydrogen is gas, water is liquid, carbon dioxide is gas, and then of course etc. For the titration one, we are looking more towards of both acid and both reactants must be soluble in water. Then and one of it that really fulfills this part is actually your acid and alkali, which is also like base but soluble base, giving you salt plus water. Okay, so generally this is how you choose. So like I say, it is important that you know which salt is soluble, insoluble, because that will help you to choose what is the method. Okay, after you have decided on what is the method already, you will then be required to identify what is a suitable reactant. And one way to help you to see what reactant is, you always remember, fall back again on the 3-word equation from acid-base reaction. Okay, so these are what I have already shared about. So when we look at method 1, and in this case we are looking more at crystallization. So this is already established that number 1, the salt is soluble. Number 2, the starting material, which is one of the reactant, must be insoluble. And like these three reactions, right, we fall it back on the acid reaction chapter, acid and alkali chapter, where the 3-word equation of what the acid can actually do lah. Okay, so in this case, what are some of the examples of metals? You will see that your metals, they tend to form from your group 1, group 2, group 3 metals, maybe a little bit from your transition metals. But most commonly coming out is your group 1, group 2, group 3. Now, they try not to also touch any of the elements that is after proton number 20, because those can tend to be quite reactive whenever you react with water, with acid. Okay, so next is insoluble. Insoluble base, they tend to have oxygen at the back, oxide at the back, or hydroxide. Okay, so these are the ones, but the meaning is still there. You see, it's still attached onto the respective metal, so the reaction can still occur. It's just that you see which form you use. Then of course carbonate again, see the metal is inside, but you are just attaching it to a different portion, which is your carbonate. And the acids that we usually use are hydrochloric acid, nitric acid, and sulfuric acid. These are the common ones, and all these are actually aqueous, which means they are soluble reactants. On the other hand, all these here, they tend to be insoluble reactants. Okay, so these are the 3-word equations with the respective forms that's produced. But whenever a follow-up question they ask you is what's the chemical equation, always remember to include your state symbol, where hydrogen gas, all your gas there's only 2 gas, water is always liquid form. The salt, because this method crystallization covers only for soluble salt, so all your salt tends to be aqueous. And for your acid, right, because your reactant is an soluble here, so So in this case it's aqueous. The only thing that is insoluble is the other reactant. Okay. So from all of these, if we were to, so this is a list of examples of what the metals you can use and the different combination you can use to create a salt. Now, for insoluble metals, base or carbonate, you tend to actually use in excess. Why is this important? This ensures that all the acids are being used up. Why? Because what we want is a complete reaction. We do not want to waste any form of material. And when it's all used up, then the insoluble one can then be slowly filtered from the salt solution at the end of the reaction. So for this portion, if you are still very unclear with the steps of crystallization, please go back and revise the chapter on separation technique. So just to have a view of what crystallization is like is this following step, which is how you should answer your question. Number one, always state in your answers if they ever ask you to prepare a salt is, what salt are you preparing? Is it soluble or insoluble? In this case, zinc sulfate, if you remember, because it's a sulfate, okay, therefore it is actually soluble. So it's soluble. So your first mark will say like zinc sulfate is soluble or it's an insoluble salt. Secondly is the name of the steps of the name of the process that you want to use. So you can say because zinc sulfate is soluble and that the reactants that you will be using is insoluble, therefore you will use crystallization. Be very clear with what are the reactants you use by, and how to be clear with that, you write the chemical equation, okay, with the state symbol. Make sure your chemical equation is also balanced, because what will tell the examiners whether you have used the correct way is the state symbol. Okay, so next, after that, what is the subsequent marks? The subsequent marks are then the process of how you actually do the steps, which is number one, you add excess zinc powder into dilute sulfuric acid. In this case, we are trying to prepare zinc sulfate, but of course, you can always twist and change. So depending on these highlighted words, you can change whatever the names that you use. So in this case, we look at zinc sulfate. You add excess zinc powder into dilute sulfuric acid and you stir until effervescence stop. Why? This will actually indicate that all the acid has been used up already, and and adding extra or excess powder, there is no use at all. Okay, then after that you filter to remove the excess zinc powder. Okay, and hence you collect the filtrate of zinc sulfate solution. So what is filtrate? Filtrate is basically the solution that has undergone filtration. So this is known as the filtrate. And what is kept here, the excess zinc, these are actually your residue. Okay, so remember that if let's say add too much zinc, and the zincs that are unreacted will actually be here. So these zincs tend to be unreacted. After that, what do you do? With the filtrate, you heat it up. So this is where the evaporation to dryness begins, where you heat the filtrate and you obtain a concentrated zinc sulfate solution. And lastly, you test for saturation by using a glass rod. You realize that there are crystals actually formed. So in this step, right, in this step here, if you overheat, you will lose a lot of water of crystallization if you overheat. Okay, so always make sure that, you see, it takes time for the solution to cool, so leave a little bit of water first, then you turn off your Bunsen burner, because when you turn off your Bunsen burner, the crystals are still actually the solution is still heated up, so leave a little bit of water so that it takes the time to actually cool it, and this water surrounding it will slowly evaporate, then you can dry and things like this. Okay, so after that, what you do, you leave the solution to cool, to allow crystallization to begin, and subsequently you filter these crystals and you wash it with cold distilled water now, and then subsequently dry. do not use too much water to wash it, because you are making it again containing too much water. Then it defeats the purpose of you actually trying to heat it up to remove the water. So you can wash it a little bit and then remember to dry it with filter paper. And that will conclude the steps. And that will actually conclude the steps of crystallization, and that is the first method. Now again, a re-emphasis is this method is not suitable for some metal because these metals can be very explosive and very reactive. What are these? They are your potassium, your sodium, calcium. And if you remember in your periodic table chapter or reactivity series, they tend to be even reacting very vigorously with the water. So what you can do with this is for all these salts, right, you will want to use other forms of method rather than the metal plus acid. You can use a carbonate with the acid, or a base form of this with the acid. Okay, so at the same time, there's also the other spectrum where some of these metals, they tend to be unreactive. So when these metals are unreactive, right, even you put it at the metal with the acid, they do not react. So what you want to do is mainly to use other forms, like again the carbonate, the hydroxide, to actually try to react it. And this method of crystallization is usually more suitable for moderately reactive metals like a zinc, magnesium, aluminum, iron. Okay, so let's say we use insoluble base. Just now we were using actually metal. So for insoluble base, you realize that the reaction is all the same, whereby you react with excess of the base, some heating involved, stir until no more copper oxide is dissolved. You filter the mixture to remove the excess copper oxide that you use. You collect the residue. You collect the filtrate. You heat the filtrate, cool and crystallize, filter, wash and dry. So these are the 6 steps that you need to know for your answers. Again, carbonate, same step. Excess of the carbonate with dilute acid until the effervescence stop. Filter to remove the excess magnesium carbonate or the unreacted magnesium carbonate. You collect the filtrate, heat the filtrate, cool, crystallize, filter, wash and dry. So it's the same process again and again. Next, we look at the second method, which is titration. So for this criteria is the salt has to be insoluble. The starting material for both have to be soluble. So one very common fit is you use acid and a base, a soluble base, which is your alkali. And after that, your reaction, this is more suitable. This step is more suitable for preparing your reactive metal, which is your spar salts, your sodium, your potassium, and your ammonium salts. Now, how to do titration then? Okay, for this kind of reaction, there is one common one that you need to know, which is the acid plus base gives you salt water. And this is your neutralization reaction. So your acid is in aqueous, base also in aqueous, salt also in aqueous, and water is in liquid. So one way to remember, if let's say in exam, MCQ, they ask you what is the name of the salt, you look at the state equation, state symbol, and that will give you very clearly, is it titration. Titration is all aqueous except water lah, which is liquid. Okay, so there is 2 main part of this for titration, where number 1, the first part is to identify what volume of reactants you need to use. The second one is to actually repeat the experiment. Okay, however, you do not include the indicator. Now, why do we do this? Why do we repeat it without the indicator? The purpose of the indicator helps us to identify volume used, and the indicator is actually an impurity. So what you want is, after you identify the volume, you will then repeat the whole experiment without the indicator, so that you actually get the pure salt in place. Okay, so these are some examples of acid with the base to get salt and to get the soluble salt. So let's look at it of how we actually prepare sodium nitrate, where in titration, So first of all, again, identifies that sodium nitrate is actually a soluble salt, and that what happens is you are choosing your reactants that are also soluble. In this case, your acid is soluble, nitric acid. Your sodium hydroxide is also soluble, forming your soluble salt, sodium nitrate. Okay, and you write the balance equation. So how would you write it? First, you fill up the burette with dilute HNO3. Burette is actually this whole construction over here, and it is actually one of the more accurate apparatus allowing you to measure your volume. Okay, so in this case, we fill the acid inside here. Okay, and then you note the initial reading of the burette. Now, when you say initial reading, we are talking about the volume that you have actually taken. So it's the first volume. So after that, you pipette. This is another one. Pipette 25 cm cube of aqueous solution. Do take note that down here they added a 0.0 because it follows the accuracy of the pipette. That is, they are able to measure fixed accurate volume to 1 decimal place. And what you add inside, you actually add the base, the soluble base. And where do you add it after that? After you have measured it, you actually add it into the conical flask. So the conical flask is the one that has the base. After that, what you do, you add your methyl orange, which is the indicator. So this is the indicator. You add it into your conical flask, and what will happen is it will actually change color upon neutralization. Now this is important because when you change color, that's where you stop adding any more acid, and then you take note of what is the volume of acid you use to actually cause the salt to actually be produced. And of course, the solution will then change color, in this case turn yellow lah, because of the methyl orange. Next, you add the nitric acid slowly until the solution turns orange, which is the end point, and so it's from yellow to orange, and this stop, and then you stop adding any more of the nitric acid. Identify what is the final volume of the burette used. That means after you have, let's say initially you started here, you add, and then it ends here. So this is V1 and this is V2. This difference is the volume of acid that you use for salt preparation, and that's how they get the formula for V2 minus V1. Okay. So after you have already identified the volume of the acid, what do? You repeat this whole experiment from 1 to 5, step 1 to 5, without the adding of the indicator. Okay. So pipette 25 cm cube of sodium hydroxide solution into it. Do not add any indicator. Why? Because we are not interested to add in more impurities into it. Okay, what we want to do is the pure one. So second step, we just add the difference. That means the volume of nitric acid that was being used for salt preparation, and then we heat to saturate the solution, and later just cool again. So this step is very similar to your evaporate to dryness step. Okay, and that will be your second part. So if we were to compare method 1 and method 2, which is method 1 is your crystallization method, and method 2 is a titration method. What actually happens? For one soluble substance acid, you only use one for method 1, which is the acid. The other one is both of the reactants has to be soluble. For method 1 again, residue of insoluble substance can be seen when the reaction is completed. However, there is no residue seen. Why? Because you have already used the indicator to measure exactly what volume of the reactants you need to form the salt. Now comes the last method, which is method 3, the precipitation method. And the following salt can be prepared by using this method, which are all your insoluble salts. Like you have your CBL, challenge-based learning, your student leaders, SL, and of course all carbonates except your spa salts, which is sodium, potassium, ammonium. But before we actually move into that, we look at the general equation. So you will have two kinds of reactants to produce a salt, which is salt A and salt B. And of course, being salt A and salt B, they will have their own cation and anion. So what we do is we look at the end goal first. The end goal of the salt, which is insoluble, they will have a part A and a part D in this case. So the part A is your cation, and the other is anion. So what we want is the first part of the cation, the A, to come from this portion here. And the part D, the anion, to come from the other salt preparation. So in this case, one will be the first one, the other will be the second one. Okay, so if we want to rewrite the ionic equation, it will be one from the first one, which is A plus, the cation, and the D minus is from the other one, which is the anion. So for example, if we look at the one below, if you want to have silver chloride, form silver chloride, the silver has to be attached onto something, maybe silver nitrate, and the chloride must come from somewhere, which is either sodium chloride. So one very simple way to remember is, remember you always use the NO3, okay, and the other one just use the sodium. So the sodium you always tack it to the, for the reactants, the anion, sodium something anion. The other one is cation something nitrate. So that's where you can use a nitrate salt plus a sodium salt combined to get something like this, and this always stays the same, where you get sodium nitrate, where the other part, the B and the C, will come together to form your sodium nitrate. So this one standard way of remembering precipitation. It's a cheat code you could say whereby you just remember that you use something nitrate with sodium something to get the salt that is insoluble, and you always get sodium nitrate as your other reactant. Okay, so this is an example. Do you see the common thing again? You use a nitrate, you use the sulfate, you use the sodium, then of course you get the base, and this is always constant. So how do you see it is when you add them up, even though they are colorless, both are colorless, you will see what precipitate form, and what you do is you just try to remove the white precipitate. Okay, so in this case, barium nitrate solution, you add with sodium sulfate solution, you stir, it will react, and then therefore you will see a precipitation form. So previously we always see we add until excess is formed, right? Over here we try not to do it because the white precipitate form is the thing that we want to filter out. So after we have filtered out the barium sulfate, this tends to be the impure substance. Okay, so after what you should do, you wash it. You wash the impure substance with some cold water to remove the impurity, because some of this impurity can be soluble. And then you dry it with your filter paper, and therefore leaving it to dry, and you get the salt. Okay, so in a nutshell, this is all the ways that you can go about doing it. This has been explained just now already. And this, hopefully when you want to revise your work, do remember all this. So precipitation trick is you use something nitrate with sodium something to get the insoluble salt, and you will get the other salt, which is actually sodium nitrate. Titration, both must be soluble. There are some carbonates that are soluble, and they are tentatively used mainly for your spar salts, because your spar metals, your sodium, potassium and ammonium, they tend to be very reactive. Finally, if all methods all fail, you want to still create soluble salt, then you try the crystallization method. But do take note that while acids is soluble, the other one must be insoluble. And what reaction you should fall back on? Acid-base reaction, acid chapter again, the 3 reaction: acid with the metal, acid with the insoluble base, and acid with the insoluble carbonate. Okay, so this is the all that you have to know for preparation of salt. Next, we will be looking into qualitative